Today we'll start a new topic. Composition of functions. I want you to think of composition of functions as just peeling stuff off in layers. And this particular chart, I'm telling you what the x values are going to be. So f of x, which says when x is minus 3, f of x is minus 9. So you put in minus 3 for x and you get out minus 9 for y. If you put in minus 3 for x on the g function, you would get out 3 for y. So if you're going to do f of g of 2, and I'm look at it, you peel it in layers, so you look at g of 2. Well, g of 2 is minus 2. Now forget where that came from. G of 2 is minus 2. Now you look for f of minus 2. F of minus 2 is minus 7. So there's your answer. Now, let's look for f of g of 0. G of 0 is 0. G of 0 is 0. Now, f of 0 is minus 3. Now let's find g of f of 2. Well, the first thing we're going to do is find f of 2. F of 2 is 1. Now we're going to find g of 1. When x is 1, g of x is minus 1. Peel it in layers. You do the inside first, and then after you do the inside, you do what's left. What it really boils down to, the y value that you get inside becomes the x value that you're going to use for the next one. Now you've got one just like this. Of course, I think it looks a little bit smoother on your computer screen, but I simply give you two graphs. This first graph that has a little curve in it, I called f of x. This second graph that has the straight line in it, I called g of x. So he wants us to find f of g of 3. So the first thing we're going to have to do is find g of 3. Well, on the g function, g of 3 is minus 1. Now, we have to find f of minus 1. Well, on the f function, when x is minus 1, y is 6. All right. Then we want to find g, f of g of 4. Well, on the g function, g of 4 is 0. G of 4 is 0. Okay. So now we're going to find f of 0. Well, when x is 0, y is 7 on the function. I'm going to circle the answers. All right. Now we want to find g of f of 0. Well, and then we now let's find g of f of 3. F of 3, and x is 3, y is 1 on the left function. Now we want to find g of 1. Well, g of 1 is easy, but that is the point 1. Have to be 1. So I'm going to say it again. You look at the inside, you get the value for it, then you look at the outside. Now, I think it's going to make more sense to you when we use equations instead of graphs and charts. So if I tell you that f of x is 5x, and I tell you that g of x is x plus 7. Okay, if I ask you to find f of g of 2, well, the first thing you're going to find is g of 2. Well, g of 2, let's plug it in here. G of 2 is going to be 2 plus 7, which comes out to be 9. Now, we're going to find f of 9. F of 9 is going to be 5 times 9, which is 45. All right. Let's find g of f of 1. All right. F of 1 is 5 times 1, which is 5. Now we're going to find g of 5, and g of 5 is going to be 5 plus 7, which comes out to be 12. So you can see with the equations, it's much easier to do that composition of function. So if I tell you that f of x is equal to x squared, and I tell you that g of x is equal to x plus 3. So let's find f of g of 1. Well, g of 1 is going to be 4. And f of 4 is going to be 4 squared, which is going to be 16. Let's find g of f of 2. All right. F of 2 is going to be 2 squared, which is 4. And g of 4 is going to be 7. You work your way inside out. Now, we're going to use this one probably in the next section, but let's go ahead and do it. If I tell you that f of x is x squared, and I tell you that g of x is the square root of x, something interesting happens here. So let's do f of g of 9. Well, g of 9 is the square root of 9, which is 3. But f of 3 is 3 squared, which comes out to be 9. Let's do another one. Let's do f of g of 25. Well, the square root of 25 is 5, but then 5 squared comes out to be 25. So look what's happening. When we put in 9, we get out 9. When we put in 25, we get out 25. And as I said, that's going to come up a little bit later. Let's do it the other way. Let's do g of f of, well, let's say 4. All right. So f of 4 is going to be 4 squared, which is 16. Now, g of 16 is the square root of 16, which comes out to be 4. So look at it again. When you put in 4, you got out 4. The other time, when you put in 25, you get out 25. And that has a pattern that we're going to use. If I tell you that f of x is equal to 2 divided by x minus 5, and I tell you that g of x is equal to, let's say, 9 divided by x. Now, we run into a little trouble with this thing right here, because the first thing we're going to have to do is talk about domains. Look at this right here. The only value that I can't use for x is 5. X can't be 5 because that would make this denominator 0 right here. X can't be 0 because that would make this denominator 0. So those are the first two restrictions on it. Now, watch what happens when we do this. I want to do f of g of x. Well, it's 2 divided by g of x, which is 9 over x, minus 5. So this is the composition of function. But we got to get rid of this fraction within a fraction. This thing is called a complex fraction. So I'm going to multiply the top by x, and I'm going to multiply the bottom by x. So I'm going to get a 2x, and then I'm going to get a 9 minus 5x. Okay, so this is the composition of that function, 2 divided by 9 minus 5x. But look right here, 9 minus 5x, if you set that equal to 0, 9 is equal to 5x. So 9 divided by 5 is going to be x. So this thing says that x can't be 9/5. So be real careful when you're working that, because the limit on the domain, x can't be 5, x can't be 0, but with the composition, x can't be 9/5. All right, let's do another one straight out. If I told you that f of x is equal to x plus 3, and I told you that g of x is equal to x plus 5, then let's find f of g of 2. Well, g of 2 is going to be 7, and f of 7 is going to be 10. Now, watch what happens when we do this. Let's try f of g of x. All right. So g of x is x plus 5. So I want f of x plus 5. And f of x plus 5 is going to be x plus 5 plus 3. So the answer comes out to be x plus 8. Composition of function. You work your way inside and outside. One of the things that you have trouble with is when you have a fraction, and keep in mind that you have to take care of the domain, because we can't use anything that would make the denominator 0. Okay, that's 6.1.